this is basically the Raspberry Pi 3 layout. So there is two USB, Ethernet port, audio or video jack, camera connector, HDMI port, micro USB power, DSI display connector, and GPIO breakout pins. Ethernet port is to connect to the Wi-Fi and the internet. For the HDMI connector, port provides digital video and audio output.
Hi, my name is PUTERI and I will explain about the component of our project. So we have the output and the input. In our project, we have 6 output and 3 input. I will explain about the function of each output and input. We have 6 output, which is relay A, relay B, solenoid 1, 2, 3 and 4. The function of relay A is for the continuous motion, while the relay B is for the changing of direction. When we press relay A and relay B, the box will move in one direction. But if we switch off relay B, the box will change its direction according to the conveyor. So for the solenoid 1, it is a single actuated cylinder. And as you can see, on cylinder 1 we have magnetic sensor, which is magnetic sensor is the input. For solenoid 2, 3 and 4, it is double actuating cylinder. For the input, we have 3 input, which is the left sensor, right sensor, and the magnetic sensor. The magnetic sensor is used to detect the status of cylinder, whether it is contracted or expanded, while the left sensor and the right sensor is used to control the dropping of the ball. In our project, we also use pneumatic system, which is the air compressor supplies the compressed air to activate the cylinder. Thank you.
So this box is basically made by recycled material, which is the cardboard. And also in the front side, we use transparent plastic cover so that it is easy for us to observe the ping pong ball drops into the box. And on the top side, we use coin for sensor to sense and drop the ping pong ball. And for the process of making this box, firstly we have to measure the dimension of the box, which have to be fixed on the conveyor, and it is enough size to fit in the box. And after the measurement, we have to cut the skirt and the plastic, and we combine it by using the surfing tape. And that's all.
Now I'm going to talk about the setting up of mechatronics system. First of all, as we can see from the picture, at the upper left there is a PLC. PLC is act as the power supply to supply the voltage to the input as also the output of the mechatronics system. And there's 2 feeder located at the left and also the right. The feeder will allow the ping pong ball to pass through it. And there's also 2 sensors which is located at the left and also the right. The sensor will send the box when the box is passed through it, and it will actuate the solenoid so that it will allow the ping pong ball to drop into the box when the conveyor is moving. And this is the picture which showing Raspberry Pi, which act as the microcontroller which control the overall mechatronics system, as well as the interface circuit board. The interface circuit board which is allow all the input and output, as also the power supply and the Raspberry Pi to connect together. For now, I'm going to describe about how does the mechatronics system work. As we can see, for a mechatronics system to work, there is actually needs 4 elements, which is the power supply, input, output, as well as the microcontroller. In this project, the power supply, which is the PLC is supplying the current, and the input, which is the sensor, and the output, which is the cylinder or the solenoid, and as well as the relay, and the microcontroller, which is we are going to program it by using the Raspberry Pi to program so that the mechatronic system can work together. In this project, we have 4 input as well as 6 output. First of all, for the input, we have 2 proximity sensor and also 1 magnetic sensor and 1 DHT22 temperature sensor. For the output part, we have 4 solenoid and also 2 relay. This is the GPIO that we use for our input and also our output mechatronic system. First of all, for the left proximity sensor, we are using GPIO 20. For the right proximity sensor, we are using GPIO 21, and the magnetic sensor, we are using GPIO 16, and for the DHT temperature sensor, we are using GPIO 12. For the output, relay A, we are using 7. For the relay B, we are using GPIO 8. For the upper left cylinder, we are using GPIO 14. For the lower left cylinder, GPIO 15. And on the other side, for the upper right cylinder, we are using GPIO 23. For the lower right cylinder, using GPIO 24. Now I'm going to describe a little bit about how the connection works. First of all, as we can see from the upper left hand side, it shows that the power supply 24 volt. This is the PLC. PLC will supply the current. As we can see, it will supply the current to the sensor as well as the solenoid. First of all, we look at the sensor. Sensor have 3 wires. First of all, which is the brown, blue, and also the black. The brown color which need to connect to the positive, so that it will have the current flow supplied by the PLC, and the blue color will need to connect it to the ground because it is the ground wire, and the black we need to connect to our GPIO, which is the Raspberry Pi because it is the sensor wire. And for the output part, as we can see for the solenoid, there's R there. The R is the red color which need to connect to the power supply, and for the black color we need to connect it to the interface circuit board. The interface circuit board showing that first is the GPIO, which is we need to connect it to the GPIO for our respective cylinder or the output, and the black color for our output, which need to connect it to the interface circuit board. And for our 6 output, we need to connect all, and after that there's a ground. The ground, make sure that for the sensor as well as the output ground, which is the input and also the output ground, need to connect it together, as well as the GPIO ground, all need to be connected together.
Firstly, the conveyor starts to move to the right. When sensor left sends the coin on top of the box, the conveyor stops. 2 balls then drop into the box. Then, the conveyor starts to move to the right again. When sensor right sends the coin, the conveyor stops. 2 balls drop into the box. And then after 3 seconds, another 2 balls drop into the box again. Then, the conveyor starts to move to the left. When sensor left sends the coin, the conveyor stops. 2 balls then drop into the box. Then the conveyor moves to the right and end the process.
Firstly, general purpose input and output, which is GPIO, is imported into command, and we label it as GPIO. So relevant features such as time and exit are also imported for further usage afterwards. Sleep is also an important command for controlling the conveyor system. After that, input and output of the system are also labeled according to their respective GPIO pin numbers. And for the cylinder and the relay and the sensor, cylinder and relay are defined as output, while sensors are defined as input. Next, the system is not executing while loop and is always true, so that it will run the given command except when it is interrupted. From the first line, the humidity sensor will start to detect the humidity and temperature of the surrounding and will display as temperature in X degrees Celsius and humidity in Y%, where X and Y are the real values of the parameter detected respectively. Temperature and humidity will display for every 3 seconds. After that, the conveyor will start to move as both of the relays are set as high, so that the conveyor will move to right hand side, and all the cylinders will be extended. The piston will be extended as they are set as high output also. Then the system is now executing a given condition such that when left sensor receive a false input and right sensor receive a true input, the conveyor will stop its motion. And then the top left cylinder will contract and the magnetic sensor on it will receive a true input, and it will display ball is start dropping now. This means that if the magnetic sensor receive a false input, means that the cylinder is not contracting, so the balls will not come out. After that, the cylinder will contract the first time for the first ping pong ball to drop, and then extending again, and the bottom left cylinder will contract and extend it again by giving them high output and low output, where high output is for extending and low output is for contracting. Contraction and extension of both left cylinders will repeat once so that the second ping pong ball will be collected by the container. Then both relays will execute high output again, and the conveyor belt is now moving to right again. From the coding, the last sleep command is given to delay the left sensor's detection to prevent that the if loop is continuing looping infinitely. Here is another condition for the conveyor to stop its motion. When right sensor receiving false input and left sensor receiving true input, both relays will execute low output to stop the conveyor. Top right cylinder will execute low output to contract its piston, and same for right bottom cylinder, and the ping pong ball will drop from feeder into container. Contraction and extension of pistons of both right cylinders are repeated again for the fourth ping pong ball to be dropped. After collecting the fourth ball from the feeder, the conveyor will still stop for 3 seconds, and then the contraction and extension of the right cylinder is repeated 2 times for another 2 ping pong balls to be dropped. After collecting 4 balls from the right feeder, the conveyor is now executing code where relay A is high output while relay B is executing low output to change the direction of conveyor belt. As mentioned above, the sleep command at the end is to prevent the delay of right sensor's detection. Then the container will now move back to left hand side. Left sensor will detect the container, and the first if condition is achieved again, so the first if loop will be executed again to let the last 2 ping pong balls to be collected.
My name is HUDA, and I will talk about the learning outcome from our project. So basically, I learned about PLC and program diagram, and I able to use Raspberry Pi in the project and learn new things from Mechatronics project. That's all. Thank you.
So for the learning outcomes, I am able to identify the basic element used in an electrical actuation system, and I am able to design the hydraulic and pneumatic used in various actuation and control elements. That's all.
From the learning outcome, we know how to set up the wiring to control the conveyor belt and to connect each component. We also learn how to write the code for the Raspberry Pi to control the sensors and activation system.
From this project, the learning outcome which I'm able to integrate between various sensors and also the actuation system such as the solenoid by using Raspberry Pi as the microcontroller to design the mechatronic system.